Welcome to Incipient Ed Labs, where mathematical concepts are made easy through innovation and research. So today we'll be working on differentiation and we'll cover two aspects of it, the general rules as well as examples on the general rules and polynomials. So now what's differentiation? Differentiation is a measure of change between two variables or two parameters. As one parameter is changing, what is the change, metered change on the second or the other parameter? So it's the rate of change of one variable with respect to the other variable. Now in terms of independent variable x and the dependent variable y, we express differentiation in terms of dy by dx. And that's because y is expressed as a function of x. And in the same vein, if v is expressed as a function of u, like in the form v equals to u and then maybe the arithmetic relationship between v and u, because v is what is at the left hand side and u is what is at the right hand side, to express that in terms of differentiation or differential value or derivatives, it's going to be dv by du. So by terms of rule, whatever variable is at the left hand side is expressed in terms of the variable at the right hand side. Now we're looking at the general rule of differentiation. Given that y is a function of x and we have y equals to x raised to power of n. Now our dy dx, that is derivative of y or differential value of y with respect to x, will bring down the power. It becomes the coefficient of x, then we subtract 1 from the original power. So the rule is bring down the power to become the coefficient of the variable, then subtract 1 from the power. And by extension, if there is an existing constant beside variable like a, then as the power is coming down, it's going to multiply that constant. We are still subtracting 1 from the original power. So bring down the variable. So bring down the power, subtract 1 from the original power. That is the general rule of differentiation. Alright, now let's look at examples. First example, differentiate with respect to x. You see WRT in a bracket. Anyway, you see that it means with respect to. Differentiate with respect to x. Y equals to x to the power of 6. Y equals to x raised to power of 6. As we have learned from the rule, we say bring down the power and subtract 1 from the original power. So you see now, from what we have on the slide, dy dx, immediately you differentiate. The y is no longer written, it is now dy dx. So we have dy by dx equals to 6 has come down based from that arrow. Then you see we have to the power of 6 minus 1, subtracting 1 from the original power. Now our dy dx becomes 6x to the power of 5, 6x raised to power of 5. Alright, this is another example. We are differentiating with respect to x. Y equals to negative 2x raised to power of negative 5. Y equals to minus 2x raised to power of minus 5. As the rule says, bring down the power, subtract 1 from the original power. So you observe from this example that we have an existing coefficient, right? A constant beside x. And as the rule says, when we are bringing down the power, it's going to multiply that existing coefficient. So we have minus 5 times minus 2, which will give us 10. Then we subtract 1 from the original power, minus 5 minus 1, and that gives us minus 6. So when we differentiate minus 2x raised to the power of minus 5, it's going to give us the y dx equals to 10x raised to the power of minus 6. Now we are in example 3. Find dy dx if y equals to 8 times root x. Now, this is quite tricky, so it has to be expressed in the proper form so that we can differentiate. So from what you see, the arrow, y is equals to 8x raised to power of 1 over 2. The square root now has turned to power r for power 1 over 2 if you are familiar with indices. So by that now we can now differentiate. So dy dx is equals to, according to the rule, the power will come down. We have 8 as the existing coefficient. With the power coming down, now we have 8 times 1 over 2x, then we subtract 1 from the power. So we have 8 times 1 over 2x raised to power of 1 over 2 minus 1. 8 times 1 over 2 will give us 4, right? And 1 over 2 minus 1 will give us minus 1 over 2. So our dy dx then equals to, now according to the law of indices as well, if we have x raised to the power of minus something, we can change it to fraction, right? I believe you still remember that. So that gives us 4 over x raised to the power of 1 over 2, and then we can change the power of 1 over 2 back to square roots. Hope you understand what you have done. If you don't, please hit me up so that we can explain it better. At example 4. Example 4 is, how should we call it, somehow more involving. It's another format in which a question can appear. So we have to find dy dx if y equals to 3 over square root of x. Like we did in the other question, that's example 3, we have to express in the proper form so that we can solve. So you see, we have our 3 over x raised to power of 1 over 2. The square root now has been changed to the index form of 1 over 2, which also is expressed according to the law of indices that we have mentioned earlier, to 3x raised to the power of minus 1 over 2. So now the general form of differentiation, bring down the power, subtract 1 from the original power. So we now have 3 multiplying minus 1 over 2. Minus 1 over 2 is the power. So we have 3 multiplying minus 1 over 2x raised to the power of minus 1 over 2, then minus 1. We have brought down the power, we are subtracting 1 from the power. So if we do the arithmetic, 3 times 1 minus 1, we have the minus 3 over 2, and then we have x raised to the power of, when you do minus 1 over 2 minus 1, it's going to give you minus 3 over 2. From there, to simplify further, we now have dy dx equals to minus 3 over 2 times 1 over x raised to the power of 3 over 2. See, we have applied the law of indices as well there again. We have removed the negative power, and then we have expressed in terms of numerator and denominator fraction. Then after that, we have our dy dx equals to minus 3 over 2x raised to the power of 3 over 2. This example 5, it's related to polynomials, and we are applying the same rule that we have learned. The question says find dy dx if y equals to 2x cubed minus 5x squared plus 2. As we have been doing, bring down the power, subtract 1 from the original power. So first term, 2x cubed, 3 is the power. We bring down the power, then times the existing coefficient of x, which is 2. Then we subtract 1 from the original power, so we have 3 minus 1. Then second term, which is 5x squared, so we have minus before it, minus 5 times 2 raised to the power of x minus 1, or it could be minus 2 times 5 raised to the power of 2 minus 1. Now when you differentiate a constant, that is a number without variable, it's going to give you 0. That's why you don't have anything behind that again. So 3 times 2 is 6, x squared, then minus 5 times 2 is 10. Thank you for watching the video. We hopefully soon we will do an assessment on this, and we will upload more videos covering more subtopics under differentiation. Thank you.